Hi, everyone, and welcome. My name is Dale Kim. I'm the Senior Director of Technical Solutions at Hazelcast, and I'd be very happy to talk about Hazelcast, give a quick overview of our technology, and explain how it fits into the cloud. So first, let's talk about what is Hazelcast. So we'd like to call it a real-time intelligent applications platform. And what that means is essentially an open source software platform that manages data and helps you to build and deploy applications, especially ones that have very stringent throughput and low latency requirements. And so to just talk a little bit about our description, Hazelcast instantaneously unifies real-time data streams with context from traditional data sources. So real-time recent data with historical data to create these intelligent applications. And intelligent applications meaning that there is a lot of business logic embedded, there's some element of automation, and there's a lot of data involved. And that's all about being able to help out with revenue, cost, and risk strategies and initiatives to achieve competitive advantage. So give an example of how it might be deployed. And I'll talk a little bit more about the architecture soon to give you a sense of the pieces and how it might fit into an infrastructure. But just quickly as an overview, as a high level, in this diagram, you see applications and data sources at the top. And then you see Hazelcast deployed across multiple sites. So you might have a legacy environment with mainframes that power many operations and businesses throughout the world to this day, and they work extremely well. They're extremely fast and reliable, but how do you add on more capabilities? And that becomes the big question, especially when you're using this technology that has less of a talent pool for building new applications. And what about some of the private clouds you might be deploying on premises, or even some of the public cloud deployments in any of the major vendors? And so what Hazelcast can do is act as that unified data plane across all of these environments. So fully support this hybrid cloud model where you can continue using your existing infrastructure, but add on new capabilities in a very easy way so that you can use some of these modern capabilities that companies throughout the world are implementing as a means of trying to gain more advantage in business. So let me talk a little bit about the architecture. So this is the general ecosystem of Hazelcast with us in the middle, and then there's supporting components around. And I'll drill down into each of those. So let's first start about the platform itself. And it largely is composed of a compute engine and a storage engine. And so in these days, particularly in the cloud, when you think about some of the major trends like the separation of compute and storage, what we try to do is actually combine those two together in kind of a microcosm of the cloud for the purposes of high throughput and low latency. So certainly computing and storage, when they're decoupled, has a lot of advantages, especially around independent scaling. So you get a lot of flexibility there. But there are times that when you're dealing with operational data, with transactional data, that you want to combine the two and have a storage mechanism that captures some of that large-scale reference data, and then a compute element to be able to process that data quickly. And so the compute unit for us is about stream processing as well as batch processing. And so with some of the data, the recent data that we want to operate on, we have connectors to plug into a wide variety of data platforms. So whether it's Kafka or a data lake or databases or data warehouses, you can plug into them, read in data, and then you have this storage mechanism, an in-memory storage mechanism where you have very fast access to data, and then the compute element upon which you can write applications. So our APIs allow you to access the data, and you get advantages around data locality and some other optimizations like near cache, where it's a second level cache that will eliminate network accesses even further to try to improve the performance. And then after doing some processing, you can store it locally again inside Hazelcast, or you can send it out to some other destination as a sink for data processing. And so we provide a number of client user interfaces.
So Dale, would you call Hazelcast a data warehouse? Is that how you would?
Data warehouses are really good for collecting a whole bunch of information, indexing and optimizing them, mostly for analytics. And in some cases it's for storage, but we're the layer next to it that allows you to do a lot of operational work. So handling transactions, perhaps doing some transformations, calling out to machine learning. So it's a very good complement to data warehouse.
I have a question about the architecture. I mean,
Sure.
you mentioned private and public cloud, but there are many organizations now that are deploying edge infrastructure to do a lot of analytics at the edge. So is there a combination of, cloud and edge that you can do with this product? I mean, caching data locally at the edge, or getting data streams at the edge and start, combining these sources at the edge, or this is only for, very large and complex infrastructures?
Yeah, I'm glad you mentioned that. So some of the challenges around deploying at the edge involve the fact that you have limited space and therefore you have limited hardware. And in fact, Hazelcast was designed for that type of environment. So it was intended to be lightweight, easy to integrate. So we're absolutely ideal for edge deployments. So whether you want to have some filtering so that you limit the amount of data that's sent over the wire to a centralized cloud data center, or if you want to have these intelligent applications that do all the processing and do all the automation in that remote location, we support both models, and that's due to the architecture that is lightweight and allows you to run on these limited hardware environments.
Gotcha. Thank you.
Great, thanks. And so with support for these client libraries that allow you to build applications in some of the more popular languages like Java, C#, Go, Node.js, and so on, and Python as well, plus a module for querying and updating data in SQL. This covers support for a wide range of developers, and that type of model is particularly good for microservices, where you have independent teams working on individual microservices as part of a bigger application. So having the ability to access Hazelcast, in a very easy and flexible way is ideal for these microservices that are being deployed in the cloud, both public and private. And then finally, there's the reference data or the systems of record that we access, that we take in data for the purposes of that high-speed processing. And so this is where we interface with these existing relational databases, data warehouses, data lakes. And so we're not about storing all the data and providing all the indexing. And that tends to be a very high cost type of effort when you're trying to combine all data sets into one repository. And what we do is selectively pick data based on some of the information that's needed for an immediate query or a set of queries, pull that in, do some processing, and then move on. And so that's why a lot of these transactional type of environments are good, but also some of these on-demand and real-time analytics environments are really good for what we do.
How complex is to integrate Hazelcast with existing application? I mean, is the interface standard like an SQL-like interface, or do you need specific API? Is there any standard that you can leverage to build your application?
Yeah, absolutely. So having SQL is a standard that we support for creating your applications. Again, supporting in those various programming languages. The integration aspect into an existing infrastructure involves using our out-of-the-box connectors. So we provide an API that allows you to write to these different data stores, but we also have some of them pre-built so that you can connect over JDBC or connect to other types of sources like Kafka and Amazon Kinesis.
So the compute portion of Hazelcast, is that a microservices container kind of environment, or is that a Hazelcast specific environment? I'm just trying to understand how Hazelcast, I know you mentioned microservices earlier as a way to drive Hazelcast, but it wasn't clear whether Hazelcast itself was a microservices architecture.
It does support a microservices architecture in that with the compute engine, you can certainly run it on a single node or in a single pod within Kubernetes, say, but also Hazelcast has a clustering mechanism under the covers. So if you deploy a number of Hazelcast instances, so applications that embed Hazelcast, you can configure them to auto-discover each other and form a cluster. And so that simplifies the deployment of microservices because you don't have to pre-configure which other microservices to talk to. they'll discover each other, and then they can share their data and communicate with each other. And I'll talk a little bit about that in one of the use cases.
Okay.
So one of the key capabilities that we provide is around this notion of stream processing. So an incoming flow of data, typically unbounded, that comes in, and there are a lot of technologies out there designed for stream processing. So you've got one class of technologies for stream processing, but in a streaming environment, you necessarily have to have a reference data component, and that's the external data storage below, and oftentimes that data comes from some system of record. And so you have these two otherwise complex distributed systems that you have to bolt together. And what you end up with is oftentimes introducing a lot of latency, especially when you're communicating over the wire, and then just making sure that they're synced together can be quite complex. And if there are any errors along the way, how do you accommodate that, considering these are distinct and disparate systems? And so comparing to that, what we do is integrate those two key pieces of an event-driven architecture so that there is this notion of a local storage component in memory for each of the processing tasks. And so now you have immediate access to local data, so you can take advantage of performance from data locality, but also have the global access to all your data as a result of Hazelcast clustering that connects all the nodes together to look like one big data store. And so some of the performance benchmarks we've run show that our performance is orders of magnitude faster than other systems that rely on bolting together two separate systems. So anytime that performance, low latency, efficiency, especially in the cloud, is going to be important, then Hazelcast might be something to look at. So I want to talk about one of the solution architectures for Hazelcast, and this is known as a digital integration hub, where it essentially acts as a data layer between your systems of records and your applications. And I mentioned mainframe integration earlier, and most companies with their mainframes don't want to build new applications, especially web and mobile applications, directly to their mainframe. What they want to do is have some kind of interface, an abstraction layer, where they can build their applications with modern programming languages and perhaps offload some of the work that generally is not revenue generating from their backend. And so with this digital integration hub, it's not only an intermediary store of data, but because of the processing component of Hazelcast, you can index the data, aggregate it, filter it, do any type of processing to make it more ready and more the data set more rich for the applications to consume. And so things like in the lower left, you see some example use cases. When building out web and mobile applications, a number of our customers have deployed this model to simplify that effort. And then mainframe integration, by avoiding direct access to the mainframe, you can continue using those for your operations, but at the same time add new capabilities like this in-memory data access, as well as stream processing.
So from a mainframe perspective, are you doing some sort of SQL or DB2 query to get the data into the digital integration hub? Is that how this works, or is it some sort of a stream process that's getting the data as it's being updated?
It's generally a query like SQL that pulls in that data. So there'll be an application. The application at the top might request some data. That request goes directly to Hazelcast, and then Hazelcast will request from the backend on demand.
Okay.
And then if the application makes any updates to that data, it's again talking to Hazelcast, and Hazelcast will write through that update to the backend to make sure that all the data is in sync.
And in the meantime, there's a transient storage sitting in Hazelcast to maintain all the data in flight. Is that kind of what's going on, or?
That is correct, and that is the storage component. It is all stored in memory, and then the compute takes advantage of the memory of the data in that memory.
So there's no specific persistent storage outside of the Optane solution. Is that how I read this?
For purposes of business continuity, we'll use persistence, and then there's some directions that we can go beyond that for longer term persistence. But the general goal is using the in-memory store as that transient storage mechanism for high performance computing.
And you mentioned earlier that you provide replication, and I'm not sure, across clusters. Is that?
That is correct.
And that replication is a synchronous replication or asynchronous replication?
It's asynchronous. Yeah, we can configure it either, but generally people tend to configure it as asynchronous.
All right, thanks.
Great, thanks. And this is where we fit in terms of supporting microservices. And so if you look at each of these white boxes, each of those represent a pod or perhaps even a cloud instance or a hardware node. And with each of those, or I guess maybe thinking of it as a core would be more appropriate. So you might have a microservice running on a given core with Hazelcast running alongside of it in a sidecar type of pattern. And so Hazelcast will provide the transient storage as well as the compute so that you can have applications written to using Hazelcast API, and that makes up the microservice. And in the meantime, you see in that green box, that shows that all of the Hazelcast instances are connected together. So you have this local store for your given microservice, but you also have access to all the other data. So that's a great way of storing global state as well as messaging with each other in the microservices environment. And so the difference between this and other solutions people have used is that they would have only that global store. So everything would be accessed to some external database, for example, and that creates a lot of latency. And so when you're building some of these microsystems that are intended to be high performance, having that local store and managed and shared across your environment is one of the key advantages.
Dale, does that end up being essentially a multi-tiered caching system with a small amount of local in the sidecar and then the majority of data spread across the central implementation?
That's a great way of thinking of it, yeah. And I think I'll just cover one last use case, and this is about real-time or on-demand streaming analytics. So streaming, you can think of as the continuous flow of data. In a real-time environment, that data is unbounded. So you'll keep on getting more and more data, like from an IoT stream. You can also use this type of architecture on batch data. So if you have a data lake with a lot of data, you can read it one data point at a time, and then it kind of looks like a stream. It's just that stream will eventually end as a result of the data at rest. And so using that model is really good for on-demand type of analytics. So by using a streaming engine, our advantage here is that we're so fast in reading the data that you can do on-demand analytics or handle these high volume data streams, like from millions of IoT devices, be able to do the processing in a distributed model, so across many nodes in a cluster, call machine learning models if necessary, and then send it out to the next step in the pipeline. And so performance.
Sorry to interrupt you. I'm this is not my comfort zone. I'm a bit stupid, so I would like you to clarify something for me.
Sure.
Is the whole premise of Hazelcast MO2? You need some disparate sources of data and kind of provide a unified way to push the data to other applications. Kind of provide and integrate kind of a Linux pipe somehow, which you can use to send data wherever you want in a continuous flow.
Yeah, that's actually a big part of it. So being able to connect to many different sources, being able to add context to the data that you're getting in, and then doing something with it in an automated manner. So it could be telling a machine to change settings as an automated action, or it could be to send data to some other repository for further analytics. But we by providing that compute, you have the flexibility to do a number of things at high speed and scale.
So the value proposition is that, I mean, all these things could do applications without Hazelcast, but what Hazelcast provides is a more real-time access to the data and a more integrated cluster-wide coherency of the data. Is that what you're providing here? I'm just trying to get a handle on what's going on here.
Yeah, absolutely. And one of the things we're seeing in terms of the performance advantage that we're getting is it encourages more experimentation, especially around machine learning. So if you can do something in a much shorter amount of time, then you can throw more at it with the same hardware, and in a very efficient way can do more experimentation. And you're not limited by some of these existing monolithic applications that can only run within the preset time that they've created. And so now being able to do more in that same amount of time allows them to try to do other types of things. And we've seen customers engaging in that type of experimentation to find better solutions for what we're working on, like in fraud detection.
And Hazelcast runs in the public clouds and stuff like that. So, I mean, it could run in AWS or Azure or Google Cloud, but it has to have an Optane compute. Is that?
It does not. It supports Optane, but is not required. And so, yes, we do support those, the major cloud vendors. We have a bring your own license model as well as a managed service.